Hello, welcome back to Statistics and Mathematics YouTube channel. Today I'm going to continue our series of videos on probability and counting rule, right? So we are going to learn the counting rules and we are going to use the counting rules to solve probability questions. So in the first place, what is meant by counting rule? Counting rule is the number of all possible outcomes for a sequence of event. We have about 3 counting rules. The first counting rule is the fundamental counting rule, the permutation rule, and the combination rule, right? So I'm going to take them one by one to explain so that we can really understand it very well, right? So let's tackle the fundamental counting rule. Fundamental counting rule states that let's assume that there is n observation, and out of the n observation we have about k1 possibilities, k2 possibility, k3 possibility, and so forth. So if you are asked to calculate or solve for the total number of possibilities of the sequence, we will have k1 times k2 times k3 times to kn, because first we had k possibilities, k1 possibilities, k2 possibilities, k3 possibility, and so forth. So we can continue to k4 possibilities, k5 possibilities. So if you have something of this sort, all that you need to do is to just multiply the possibilities in order to get the number of possibilities of the sequence, right? Yes. So let's walk ourselves through some examples for us to really appreciate what we are discussing about. So here, the first question says, a coin is tossed and a die is rolled. Find the number of outcomes for the sequence of the event. When we toss a coin, we know that we are going to have a sample space of a head and a tail. So the number of observation in tossing the coin, right, is 2, because you are having head and a tail. When you roll a die, we are having 1, 2, 3, 4, 5, 6 observation. So the number of observation in D, that's tossing the coin, a die, is 6. So if you want the number of outcomes, the possible outcome of the sequence of the event, what you are going to do is to just multiply 2 by 6 to get 12, right? So let's go to our second example. It says a paint manufacturer wishes to manufacture several paints. The categories includes color, type, and texture, right? Color, type, and texture, right? And then the question says, how many different kinds of paint can be made if you can select one color, one type, one texture, right, and one use? Here the one use is not part, right? So let me cancel it out so that we can solve our question in peace, right? So here is raised to the power n, right? So here, that is the question. So how many different kinds of paint can be made if you can select one color, one type, and one texture, right? So here the number of observation for the color is let's say we represent that one by k1, which will be equal to 7, because when you count 1, 2, 3, 4, 5, 6, 7, you have 7 observation. And for the texture, which will be equal to k2, is equal to 1, 2, 3, 4, right? 4 observation. And then we have texture, right? So for this texture, we have outdoor and indoor. So that one to represent k3, which will be equal to 2, right? So we know that for the number of possibilities, different kind of paint, we are going to have k1 times k2 times k3, of which you are going to get 7 times 4 times 2, to be equal to 56, right? So that will be our final answer. 56 will be our final answer. So let's go to the question 3. It says there are 4 blood type A, B, and O. The blood can also be R1 and then R2, right? So the blood can also be grouped to RH1 and then RH2. Finally, a blood donor can be classified as either a male or a female. How many different ways can a donor have his or her blood labeled? So here we have 4 blood types, right? We have blood A, B, and O. So this one, we can let the blood type represent K1, and our K1 will be equal to 4, because we have 4 different blood groups. And then we will let our RH1 and the RH2 represent K2, which will be equal to 2, because we are having RH1 and the RH2 to be the observation, right? And for the gender to be equal to K3, which will be equal to 2, because we have male and female. So if you want to know different ways for the blood to be labeled, right, we are going to have 4 times 2 times 2. That will be k1 times k2 times k3, of which you are going to get what? 16. And for our last question here, we are having, it says, the employee of a department store chain wishes to make 4-digit identification cards for her employees. How many different colors can be made if she uses the digits 1, 2, 3, 4, 5, and 6? And repetition are permitted. So here we know that the digit is 1, 2, 3, 4, 5, and then 6. Right? There is a 6. So here, comma 6. Right? So the number of digits will be equal to what? 6. And here he said he want to make what? 4-digit identification card for her employees, where repetition is what? Allowed. So if repetition is allowed, the number of ways can be what? 6 by 6 by 6 by 6. Since he wanted to make 4 identification cards for his employees. So since it is 4, we are going to just repeat our 6 4 times. So when you multiply everything, we are going to get 1,296 to be our answer. So let's continue. For us to really appreciate or understand the permutation rule and the combination rule, right now we are done with the fundamental counting rule. We are going to the permutation and then combination rule. For us to really appreciate it, we have to understand what is termed as what? Factorial notations, right? Factorial notations. So we are going to discuss the formula for the factorial notation. So the factorial formulas for any counting n, right? If you have n factorial 2 is equal to n times n minus 1 times n minus 2 times to what? Times what? N. Right? So you are going to subtract 1, 2, 3, 4, 5 from what? The n observation until we get what? 1. And then you stop, and we are going to multiply everything. So basically, let's say if you have 5 factorial here, right? If you have about 5 factorial here, how are you going to do them? So here you have 5 factorial, right? 5 factorial must be equal to what? 5 times 5 minus 1 times 5 minus 2 times 5 minus 3 times 5 minus 4, right? We cannot add times 5 minus 5 because you are going to get 0. But the rule says that we are supposed to end at what? 1. So here we are going to get 5 times what? 4 times what? 3 times what? 2 times 1. That's the reason why we had this expression here, right? So that is how we are going to expand what? The factorial notations, right? So if you have 9 factorial 2, if you have 9 factorial here, right? So I think there is a mistake here. Here is not supposed to be 5, okay? Here is supposed to start with 1, 9. There is a mistake here. So here we are going to have 9 factorial, 9 factorial is going to give us 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? The 5 is not there, right? Thank you. Yes, so that is how the factorial notation can be what? Explained. So once you have been able to appreciate the factorial notation, let's go to what? The permutation rules and then what? The combination rule. But before that, let's discuss what is meant by permutation, right? A permutation is an arrangement of n observation in a specific order. So here I'm going to arrange our n observation in what? A specific what? Order. The order is of what? An important. So let's solve some examples under permutation. While we appreciate examples under permutation, I'll introduce the permutation rule for you to really appreciate how the permutation rule also works. So the first question on the list is that, suppose a business owner has choice of 5 locations in which to establish her business. She decides to rank each location according to a certain criteria. So you see, he wanted to rank them, right? So if he wanted to rank this on a specific what? Locations, right? So once he wanted to run this on a specific location, it means that they want to rank it in what? In order, such as price of a store and parking facilities. How many different ways can she rank the 5 what? Locations? So the specific way for ranking the 5 location, right? So this one, we are just going to have what? 5 what? Factorial, right? We are going to have about what? 5 what? Factorial. Please, I'm sorry. Yes. So 5 factorial. So here we are going to get our solution, right? And here I'm going to get 5 factorial, which will be equal to 5 times 4 times 3 times 2 times 1, right? So this is what we are arranging it what in a specific order. So here we have 5, we have 4, we have 3, we have 2, we have 1. So the factorial notation is going to help us to get our different ways of ranking our 5 locations, right? So here 5 by 4 by 3 will give us what 60 by 2 give us 120 what ways. That's 120 what ways. Yes. So let's continue. Our second question says, in how many ways can the letters of the word car be arranged in order? Right? So since the car is going to be arranged in order, we have about 3 letters in the car. Right? We have 3 letters in the car. So here, solution. If 3 letters, it means we are going to have 3 what factorial, which is going to give us 3 by 2 by what 1, and then we are going to have 6 what ways. So this is what the permutation. So for permutation, we are just arranging our n observation in what a particular what order, and that order will be what n factorial. Right? For all the permutation, we are going to get what our n factorial. So here, let's discuss what the permutation what rule. Right? So for permutation rule, the arrangement of n objects in a specific order using r objects at a time is called permutation of n objects taking r objects at a time. It is written as n permutation r, and the formula is what this one, right? So this is how the formula can be expressed. So here we are going to get n permutation r is equal to n factorial divided by n minus 1 what factorial. So this is how the permutation rule is being what expressed. So if you want to arrange them in order, and then they want you to apply the permutation rule in the question, all that you need to do is to just just get your n from the question and get your r from the question. Once you get your n and the r from the question, n permutation r is just simply n factorial divided by what n minus r factorial. So the work is done. So let's dive into our question solving so that you really appreciate how these things are worked. So here we are having, it says, the advertising director for a television show has 7 aids to use on the program. For she selects one of them for the opening of the show, one for the middle of the show, one for the ending of what the show. How many possible ways can this be what accomplished? Right? So the director has television show, right? About seven of them, right? So here our n, right, is equal to what 7, and then our r is equal to what the opening show plus what the middle show plus what the ending what show. Right? And we are going to get our r to what 1 plus 1 plus 1. So our r will be equal to what 3. So since we have our r to be 3 and our n to be 7, we will just get our n permutation r to be equal to what n factorial divided by what n minus r what factorial. And we know our n to be what 7, and then we know our, so it will be 7 factorial, and we know our r to be 3. So here we are going to get 7 minus what 3 factorial, of which we are going to get 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 4 factorial, which will be 4 by 3 by 2 by 1. Right? You know that this 4 can cancel this 4, this 3 can cancel this 3, this 2 can cancel this 2, and this 1 can cancel this 1. We are left with what 7 by what 6 by 5, and then we know that 7 by 6 by 5 will give us a final answer of what 210. Right? So here we are going to get our final answer to 210 what ways. So this is how this is the total possibility for that television what show. Right? Yes. So let's go to our second question, and then here it says a school musical director can select 2 musical plays to present next year. One will be presented in the fall, and the one will be presented in what the spring. If she has 9 to pick from, how many different possibilities are there? Right? So here we know that he had a total of 9 to be picked from. right? So here our n will be equal to what? 9. And then he had what? 2 musical play to present next year. So 2 of them are being what? Selected. So here our r is equal to what? 2. So you are going to have 9 permutation what? 2, which will be equal to what? 9 factorial divided by 9 minus 2 factorial. And when we expand this, you are going to get 9 by 8 by 7 by 6 by 5 by 4 by 3 by 2 by 1, right? All divided by 7 by 6 by 5 by 4 times 3 times 2 times 1. Of which you can see clearly that 7 will cancel 7, 6 will cancel 6, 5 will cancel 5, 4 will cancel 4, 3 will cancel 3, 2 will cancel 2, and the 1 will cancel what? 1. We are left with what? 9 times what? 8. And then we know that 9 times 8 is equal to what? 72. So you are getting 72 what? Ways or possibilities, right? So let's use the ways. 72 what? Possibilities, ways, right? So right now, you have been able to appreciate fundamental counting rule, permutation rule. Let's go into our slides to discuss what we call distinguishable permutation, right? Distinguishable permutations, right? So what is meant by distinguishable what? Permutation? The number of distinguishable permutation of n objects where n1 are of one type, n2 are of another type, and so on is given by n factorial divided by n1 factorial times n2 factorial times n3 factorial times nk what? Factorial, where the summation of n1 plus n2 plus n3 plus 2 plus nk will be equal to what? Our total of what? N. So here let's say if n observation is given to you or n object is given to you, and there is some repetition of some similar objects in this big what? N. So let's say if n1 represents repetition of one object, right, repeating itself sometime, and then the n2 will be repetition of some object in the same n repeating itself another time, right? So if you see that repetition in a certain object, then you are going to use what we call the distinguishable what? Permutation. So let's get ourselves an example to solve for us to really appreciate what we have discussed about. So for example 5, we are saying that in how many ways can the letter of the word Mississippi be arranged, right? Yes, and you can see clearly that for Mississippi, you see that some of the letters are repeating themselves, especially the I, the S, and the P. They are repeating itself. So this is a permutation question, but right here we are not going to use the permutation rule to solve, but right now we are going to use what we call the distinguishable what? Permutations, right? So here we know that distinguishable permutation is what? N factorial divided by n1 factorial times n2 factorial times n3 factorial times what? Nk factorial, right? So here we know that our n will be equal to what? The total number of what? Letters here. And when you count them, the letters are what? 11, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you are having our n to what? 11 ways, right? And then our n1 will represent what? The repetition of what? The i's. The repetition of the i's is equal to what? 3. And then n2 would be a repetition of what? The x. Of it, the repetition of the x2 is what? 4. 1, 2, 3, 4. We have 4. And the repetition of what? The p will be n3, which will be what? 2. Since we have 2 p's. So once we have that, the work is done because you have been able to locate our n to be 11, n1 to be 3. Sorry, the I is 4, right? And not 3. Sorry. For the repetition for the I is 4, not 3. So here our n1 is equal to what? 4, right? So let me clean it so that you not get confused. So here is what? 4. Because when we count the I, you are getting 1, 2, 3, and then what? 4, right? So once we have our n, n1, n2, n3, no, the work is done, right? So here we are going to get 11 factorial divided by 4 factorial times 4 factorial times 2 what? Factorial, of which you are going to get 34,650 what? Ways, right? Yes, that's the permutation, right? And then for the question 6, it says, in how many ways can the letter of the word statistics be what? Arranged, right? The total number of letters here is what? 10. That's the reason why we are having 10 factorial here. T is repeating itself 3 times. 1, 2, 3. So you're having 3 factorial. I is repeating itself what 2 times. So you're having what 2 factorial. And then x is repeating itself what 3 times. 1, 2, 3. That's the reason you're having what 3 factorial again. So when you do the factorial, the division and the multiplication very well, you are going to get 50,000 what 400 what ways. Right now we have understood the distinguishable what permutation. So let's go into what the combination rule. Right. So for combination rule, it says a selection of R objects from a group of N objects with no regard to what order. So here you are having N combination R, which can be written in this form. Once it is written in this form, we can also read it as what N combination what R, which can be given as what N factorial divided by N minus R factorial times what R factorial, where our R is always going to be less than or what equal to what N. Right. So the difference between the combination and the permutation is that for permutation, the order of the object is of what important, but for combination, the order of the object is not of what important. Right. So this is the formula for the permutation rule, and when you go to for the combination, this is the formula for combination rule. Right. So when you go to the permutation too, you have the formula for what the permutation rule. So I'm going to use the combination rule to solve some question that restrict us to use what the combination what rule. So here the first question is, a newspaper editor has received 8 books to review. He decides that he can use 3 reviews in his newspaper. How many different ways can these 3 reviews be what selected? So you see, these 3 reviews, we want to select them, but we don't want it to follow what a particular what pattern. So this is strictly what a combination question. If it was a permutation question, we could see that some order will be here, right? You will see the question will be talking about some specific order of what how the selection is going to be made. But here there is no specific order. So this question is what a combination question. So here what that you have to do is to get what our N and then our R, and we could see that we wanted to select what 8 books for the review. So here our N will be equal to what 8. And then our R will be equal to what 3, since we wanted to select only 3 for the review, right? So here we are using combination, right? So here we will have N combination what R, which will be equal to 8 combination what 3, which will be equal to what N factorial divided by N minus R what factorial times R factorial, right? So here, so for this one, we are getting our N to be what 8. That is what we just wrote here. So we are going to get 8 factorial divided by 8 minus 5 factorial times, is 3. R is 3 times what 3 what factorial. So when we expand this one, we are getting 8 factorial divided by 5 factorial times what 3 factorial, because when you subtract 3 from 8, we are getting what 5. So you are going to get 5 factorial. So when you point 8 factorial divided by 5 factorial times 3 factorial, we are going to get what 56 to be what our final answer, right? So let's go to our next question. So this is our next question. In a club, there are 7 women and 5 men. A committee of 3 women and 2 men is to be chosen. How many different possibilities are there? So here we have been given 7 women and 5 what men, right? And then for the committee we have 3 women and then 2 men. So here we are going to do the combination for a woman and a combination for what a man, and then just multiply it to get our different what possibilities, right? So here we have N1 combination R1 times N2 combination R2. So the N1 will represent what? The total number of what women, which is 7. And then R1 will represent the committee being selecting what? A woman, which is 3. So R1 is equal to 3. And for N2 is equal to what? 5. Here, our N2 is equal to 5. And then R2 will also be equal to what? 2. Right? So that we are representing the R2 to be what? The men. And when you come to the, that's the N2 to be what? The men. And then for the R2, R2 represents what? The men in the committee being selected, which is what? 2, right? So right now we have our N1, R1, N2, and then R2, right? So here we are going to just have 7 combination 3, right? That is N1 combination R1 times N2 combination R2, which is 5 combination 3. So once you multiply this one together, we are going to get what? 35 by what? 10, of which our final answer will give us what? 350, right? So that is how the permutation rule also what works. So right now, since you have been able to treat the fundamental counting rule, the permutation rule, and then combination rule, we are going to apply these counting rules to solve what? Probability what? Questions. So the first on my list here is your exam's ID number consists of 7 digits. Each number can be from 0 to what? 9. And each digit can be what? Repeated. What is the probability of getting your ID when randomly generating 7 what? Digits, right? And we know clearly that probability of an event, right? Probability of an event is equal to number of what? Event divided by what? Number of what? Sample space, right? So right now we have to get our number of events. From the question 2, our number of events is equal to 1. Why? Why did we get 1? We got 1 because here he said your exam's ID consists of what? 7 digits. So you are talking about the ID here, just one ID. And when you come to the question, he says that what is the probability of getting your ID? That is just one ID, right? When generating what? 7 digits. So here our number of events is what? 1. We will add the probability of the number of getting what? A given what? ID, a certain ID, which is 1, right? So once we have the number of events, we are left with we find the number of what? Sample space in order for us to get what? Our probability. And we know that the number of sample space, we said that this digit of the ID, which is what? 7, can range from what? A choice of from 0 to what? To 9, right? So here we move from 0 to 9, so you are going to get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So right now we have 9 here, right? We have this observation here. So when we count it, we have about 10 choices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have about 10 what? Choices, right? So these 10 choices here, we are going to use the fundamental counting principle to calculate for what? Our number of what? Sample space. So since we have 10 choices for each of what? The 7 digits, we are just going to repeat 10 7 times because he said each digit can be repeated, right? So since it's ranging from 0 to 9, and then this thing is what? 7 digits, we are just going to repeat the number of choices, which is 10 7 times. So you are going to get 10 times 10 times 10 times 10 times 10 times 10, of which you are going to get 10 raised to the power 7, and we are going to get what? 10 what? Million to be what? Our number of what? Observation, our number of what? Sample space. So right now we have our number of events and the number of what? Sample space. So since you have number of events and number of sample space, what you are going to do is the probability of your ID number will be 1 divided by what? 10 what? Million, right? Yes. Let's go to what? The second question. So here we have 11 letters consisting of 1 M, 4 I's, 4 X, and then 2 P's. If the letters are randomly arranged in order, what is the probability that the arrangement spell the word Mississippi, right? So here we know clearly that our probability of what event is equal to what? Number of what? Event divided by what? Number of what? Sample space. Here to our number of what? Event is equal to 1 because of the word what? Mississippi, right? That is just a word. We are just getting the probability of arranging the word what? Mississippi. So here the word here we have is what? Mississippi. It's only Mississippi what? Only. So the number of events is what? 1. Because we are having just one word, Mississippi. What about number of what? The sample space. So for the number of sample space, we are going to use the permutation rule to get our number of our sample space, because he said if the letter are randomly arranged in what? Order, right? And then the permutation rule, we have what we call the distinguishable what? Permutation. So for distinguishable what? Permutation, under the permutation rule, we are going to have this one. We have already solved in this question, so I'm not going to waste a lot of time here, right? We are going to just have 11 factorial divided by 1 factorial times 4 factorial times 4 factorial times what 2 factorial, of which you are going to get 34,650. I've already solved this question with you. Yes, so I'll not waste my time here. Yes, so here we are getting probability for the Mississippi to be equal to 1 divided by 34,650, of which you are going to get 0.000029, right, to be what our probability, right? I'll leave this question for you to try your hands on it. When you try your hands, share it at the comment section and I'll verify for you if you are wrong or correct, right? Yes, so let's go to our last question for the day. And for our last question, it said a board consists of 12 men and 8 women. If a committee of 3 members is to be formed, what is the probability that A, it includes at least 1 woman, B, it includes more women than what? Men, right? Yes. So here we are letting M to represent what? Men, which is 12. We are letting W represent what? W represent women, which is what? 8 from the question. We are having 12 men and what? 8 women. So if you want the total observation N, it will be equal to 12 men plus what? 8 women, which is going to be what? 20. And then we see that if a committee of 3 members is selected, so here our R to be equal to what? 3, right? So we have been able to deduce our N and then our R from what? The question. Here we are going to solve for probability question. The A says we should calculate the probability that it includes at least 1 woman, right? So here we know a probability of it including at least 1 woman. 1 woman will be equal to number of what? The event, that is the number of what? Women divided by our number of what? Sample space. And you could see clearly here that we have to get our number of what? Event and the number of what? Sample space. And the number of sample space here, right? Number of what? Sample space. We see we are going to apply the combination what? Rule here to get our number of what? Sample what? Space. Right, we are going to apply the combination what? Rule to get our number of what? Sample what? Space, right? Yes, so here we could see that we have been given our N to be what? 20 and our R to be what? 3, right? So we are going to get 20 combination what? 3, which will be equal to 20 factorial divided by what? 20 minus 3 factorial times 3 factorial. Right, and then if you do the factorial and the division very well, we are going to get our final answer to what? 1140. Right, 1140. So when we come here, that is what the number of ways for forming what? The committee of 3 from what? 20. So that will be our number of what? Sample space. Right, so we have to also get the number of what? Events. Right, the number of sample space as what? Given. Have been calculated for, right? So for us to really appreciate this question, he said we should find probably that at least 1 woman. Right? So for at least 1 woman, we are going to get we see the committee was 3. So we are going to get 1 woman and what? 2 men or 2 women and 1 man or 3 what? Women. Since it's at least, we are going to move from what? 1 to what? 3, because 3 of the people were what? Selected from the committee, right? So here our woman, at least 1 woman can be what? Expressed in what? In this form, right? And we know that for W is equal to 8 and then M is equal to what? M is equal to what? 12, right? So here we are just going to use what we have here to calculate for it, right? So here we are going to get our N combination 1, since we are having 1 W, right? So here will be 8 combination 1 times 12 combination 2 for the first pair, right? Plus 8 combination 2, since we have 2 W, times 12 combination 1, since we have 1 m here, that's man, plus 8 combination what 3. So we are just going to divide it by what the sample space, of which is 1140. So when we multiply, when we find the combination and add everything divided by 1140, you are getting 0.8070, right? Yes. So that's the first question is done. So for the second question, we are having to find probability of more women than what men, right? So here in the pairing, we want to see more women than men, right? So here we are going to get either 2 women and 1 man, or 3 women and what 0 what man, right? So that is what we are going to have here, right? So here we are going to get 8 combination 2 times 12 combination 1 plus 8 combination 3, right? So once we have this one, and we are going to divide it by our total number of sample space, right? Of which when you do the division and the addition here, you are going to get 0.3439, right? Because of time, I'll leave this question for you also to try and share your comment, share your answer at the comment section for me to verify it for you. Thank you for watching. This is Statistics and Mathematics YouTube channel. If you haven't subscribed, subscribe, like and share so that this video will get to your friends. And don't forget to leave your comment at the comment section.